Hello, all. Welcome to day 3 of the daily case study series for grade 12. Today's question goes like this: LED bulbs are energy efficient because they use significantly less electricity than traditional bulbs while producing the same amount of light. They convert more energy into light rather than heat, reducing waste. Additionally, their long lifespan means fewer replacements, saving resources and money over time. A company manufactures a new type of energy efficient LED bulb. The cost of the production and the revenue generated by selling X bulbs in an hour are modeled as. So the C of X function has been given, R of X function has been given. Both are in rupees. To maximize the profit, the company needs to analyze these functions using calculus. Use the given models to answer the following questions. First subdivision, derive the profit function P of x. So P of x is equal to R of x minus C of x minus 0.3x square plus 20x minus 0.5x square minus 10x plus 150. On subtracting these two, we get minus 0.8x square plus 30x minus 150. Subdivision 2. Find the critical points of P of x. To get this, first we need to differentiate P of x with respect to x. So P dash of x will be equal to minus 1.6x plus 30. Put this to 0 to get the x value. That is minus 1.6x plus 30 is equal to 0. Minus 1.6x is equal to minus 30. X is equal to 30 divided by 1.6, which gives us 18.75. So this is the critical point. But we don't know whether this is going to give us a max or min profit. So we have to figure out. We'll move on to the third subdivision. First part in that. Determine whether the critical point corresponds to a maximum or a minimum profit using the second derivative test. So the question itself gives us the hint. We have to get the second derivative of the profit, which is nothing but minus 1.6. Since this P double dash of x is negative, now this x is equal to 18.75 is the local maximum. That is, at this value of x, we will get the maximum profit. So it corresponds to maximum profit. Fine, that is the A part. Now going to the B part. Identify the possible practical value of x. That is the number of bulbs that can realistically be produced and sold that can maximize the profit. If the resources are available and the expenditure on machines allows to produce minimum 10 but not more than 18 bulbs per hour. Also calculate the maximum profit. Based on this, what I understand is X represents the number of bulbs which can't be in a decimal form. So I take X as 18. Is 18 allowed? Yes, it is allowed. Then at this point, we have to find out the maximum profit. That is, we have to get P of x when x is equal to 18. So we will put it in the P of x function minus 0.8 times 18 square plus 30 times 18 minus 150. On calculating this, we get 130.80. We'll come back tomorrow with another case study. Thank you all.